Hello and welcome to my first official or proper video associated with Nighttime Astronomy channel. So, today's video I will be talking to you about the upcoming 2018 lunar eclipse that will be visible, I believe, in the UK and in parts of Europe. So, I'm making this video to show you not only how to observe it, but also the science behind it. So, the eclipse is happening on the 27th of July 2018, and the moon will begin to rise at 21:03 or 3 past 9, well, not necessarily 3 past 9, but roughly around 9 o'clock at night. So, the good thing about observing this is because it's simply a reflection of the light from the sun passing through our atmosphere onto the moon, and then the light reflecting off the moon, rather than the sun or the moon covering the light coming from the sun, which is a solar eclipse. You do not need any special glasses, filters, or anything that protects your eyes to prevent them from catching fire. So you can actually look at this with your naked eye or with binoculars. Not entirely sure about a telescope, but definitely binoculars. So, as I stated, this occurs at 9 o'clock, and as you can see here on Stellarium, about roughly southeast. So if you're unsure on how to determine the direction in which you're looking, you can always just look at where the sun is setting, and as we know, the sun rises in the east and falls in the west. So if you can see the sunset over here, you know that's the west, and then from there you can determine which way is south, which way is east, and which way is north. So, getting on with it, we can take a look at the moon with this wonderful program. As you can see, it's nice and high quality here. So I will click on the moon. This allows me to track it, and this tells us the magnitude, absolute magnitude, everything that we essentially need to know. Or rather, what you nerds want to know about the moon during this event. So, if we press play, we can see not only the moon rising, essentially, but also the time at which it peaks and when the total eclipse begins to end. So, if I speed up time a little bit here, I don't know, maybe that's a bit too slow, but at the moment I've got the atmosphere on. If I were to take it away, we can see that the moon is still red, and we can see that with the atmosphere, so I'm keeping that on just so you know what you'll be seeing when it's actually happening. I'm going to track this so I don't have to move the cursor every 3 seconds. So, this is going to be a once-in-a-lifetime event. It's the longest total lunar eclipse in a century, I believe, and won't be, this sort of thing won't happen again until the next century. Now, on top of the moon being visible during this eclipse, see, as you can see, it's starting to dissipate, this total lunar eclipse. I will find the time at which that occurs right now, because I was rambling. But no, also at this time, you can, if you note, Mars is also clearly visible. And the reason being is that this is the closest Mars has been to Earth in a few decades as well, and this is due to its elliptical orbit. So, with an elliptical orbit, one time of the year, Mars is closer to the Sun than another time of the year, and it's the same with the Earth. So, this also means that Mars also is closer to the Earth every now and then, depending on how the two orbits sync with each other. So if we click on Mars, we will know that, yeah, it's closer, but also, not only that, because it's closer, it's got a larger absolute magnitude. So what that means is that it will actually appear brighter in the sky. And being quite close to the moon, even though it is low on the horizon, in terms of our perception, it's not actually close to the moon, it's just our perception, it makes for some brilliant photography opportunities. So if you're an astrophotographer, you can take some wonderful pictures of the two coinciding with each other. So back onto the topic of the blood moon, or the total lunar eclipse. It will not end the bloody world. I can tell you that for sure. It's not going to end the world, as many zealots will have you believe, and cultists. It's simply a reflection of the light, or at least rather the Earth's shadow being cast on the moon. That is it. That's it. You're not going to have the world ending, tidal waves, earthquakes, because that's just balmy and impossible. It's a load of cack. It won't happen. So, as I was stating before, I believe the total lunar eclipse begins to wane, not in terms of, you know what I mean, like, it begins to fade or dissipate roughly, yeah, if we pause it here, around this time here, so around 10 o'clock. So it doesn't really give you too long of a time to witness it, but it does last quite a long time. But you'll still see the redness. It doesn't mean it instantly disappears, like all of a sudden no red moon. It'll fully dissipate. If I click back on here and track it, we can see when it will fully dissipate. And that's roughly around 11 o'clock at night. But once again, this is stellarium, so it's simply predicting the movements of the moon and the Earth, simply predicting it. So it's not actually using real-time data. Well, it is using real-time data, but it's not going to be 100% accurate. There's going to be some deviation and error. So, yeah. So now on to the science. Now the reason why the moon turns red during a total lunar eclipse, it's dependent on atmospheric conditions. So I believe it's similar to how you're filtering out wavelengths of light. This is why we see a blue sky. This is why we have a red sunset. It's due to, I believe, particle composition in the atmosphere, and they act sort of as a diffraction gate. Well, not a diffraction gate, like something that polarizes light. For example, your sunglasses or something like that. So it only allows certain wavelengths of light into the atmosphere, or into our retinas rather. So we only really see a certain wavelength. So that portion of the sky during a sunset, we only see a red wavelength, or roughly colours surrounding the infrared or the red side of the visible spectrum. And that is also the same with the moon. Now the light is refracted from the sun, which is, if we're talking in general terms, behind us. During this total lunar eclipse, it's behind us, and the moon is directly in opposition with the sun, with the Earth between the two. So the light from the sun is passing through the Earth's atmosphere and being refracted. That means that when the light passes through a medium, it slows down, which causes a bend in its sort of angle or direction. And this light is then, as I told you, polarized in a certain manner of speaking to a red wavelength. Now this red wavelength hits the moon, and that is reflected back at us. So we are seeing the moon in the refracted light that's passed through our atmosphere, which is polarized into a red wavelength. And that is why the moon goes blood red. So if we were, say, in different atmospheric conditions, I believe it goes a darker red. Yeah, it depends. I believe on the if you had less oxygen, or I'm not sure, but there are times where it can go a darker red, and sometimes when it goes a lighter red. It's all dependent on atmospheric conditions. And also, obviously, this is all depending on the weather. So if we have a lot of cloud cover, you're not going to be able to see this, unfortunately. Or you might be able to see a glint of it. So hopefully the weather's permitting, and hopefully we'll get some good views of the moon during this event. But as I stated before, remember this is a essentially once in a lifetime opportunity. We will see blood moons multiple times. I mean, we've seen quite a few this year, I believe, but to this sort of extent, where not only you've got Mars close to the moon in terms of our perception, but also the length of time at which this event occurs, and we're not going to see it for another century. So that's it. That's it for this video. I hope you enjoyed. The app I am using is called Stellarium. It's free. I believe you have to pay for it on a mobile phone on Android and the Apple Store. But on the laptop or computer, PC, whatever, it's free to download. I'll leave a link for the website in the description as well if you have an interest in downloading this, because you can also observe meteor showers. It will predict where meteor showers are, it will predict where total solar eclipses are, and partial eclipses for both lunar and total. Depending on areas of the world, you can observe it because it is a highly accurate prediction system, essentially, that uses data gathered from a variety of sources, and just using physics. So, I hope you enjoyed again, and I will be making some new videos soon. It's all dependent on whether I can actually be bothered in this heat, because it is ghastly hot, but hopefully, if my fan doesn't blow up, I will be able to release a few more videos on different topics. And speaking of which, the next video I'll be releasing will be on what is astronomy. I was planning to release that as my first video, but this is an extremely important event that I couldn't miss out covering. So, I will see you in the next video. Farewell. If I know how to switch this thing off. And